All right, so now we're looking at explicit equations with arithmetic and geometric tables. Not tables. I don't know why I didn't label this. Pictures and context. So story problems. Okay. So explicit equations. If we haven't watched any of the other videos or if we're not sure what they are, explicit connects, thinking of a table, the input to the output. So using the number here, we can figure out this number based on what's happening here. Okay, so to do that, we need the start. We also need the growth, just like with recursive. The difference is that we only make one equation and we use the pattern, which by using the pattern we actually end up, and if you want to check this out, check out the other video where I just did the sequences, because that one I do the table and show you the connection between the input and output, and it's really great. But it ends up being that for arithmetic, we end up with an equation that looks something like y equals our start number, then plus or minus our growth times x, or y equals a plus b times x. For geometric, it's y equals our start times the growth, or divide to the x power, or y equals a times b to the x. Okay, so let's take a look how we deal with that with the story problem. So first, we've got our start number here, 1 mouse, so I'm going to go y equals 1. Then how's it growing? 1 to 4 to 16, so we're times them by 4, meaning it's geometric, so my variable is an exponent, because every time I'm times them by 4. So repeated multiplication is an exponent. Okay, number 2. You want to say I'm starting with 1 duck, but I'm actually not, okay? Because that's bath 1, I've got to go to bath 0, right, to do this. So 1 duck, 2 duck, 4 duck, 8 ducks. So I'm times them by 2 each time. So another geometric, so y equals, now going backwards, we divide 1 by 2, so we actually start with half a duck, which may not make a whole lot of sense unless you're thinking about 3D printing. Then it makes tons of sense, because maybe their printer only was able to get half a duck made that first or 0 day, and they didn't bathe because that's why they had bath 0, because they only had half a duck. And then bath 1, finally they had a duck, and then apparently their printer works a lot better, or they just decided to not bathe every day. I guess either one works. All right, number 3. Again, we've got the start of 2 to 4 to 6 to 8, so we're adding 2 each time. So arithmetic, so I go y equals my start of 2, then I'm adding 2, and I'm repeatedly adding 2, and repeated addition, the shortcut is multiplication. Now, I could write this as y equals 2x plus 2 in that slope-intercept form. Same thing, but I prefer this way just because it matches up how we do it that way with geometric and arithmetic. So number 4, 3 to 9 to 27. Right, you can kind of see that thirds, and then the bigger one. Okay, and then just 1. All right, so we're times them by 3 each time. So I go y equals, and we've got to go back to day 0. So 3 divided by 3 would be 1, and we get 1 times 3 to the x. Now, could I go y equals 3x times 1? Yes, I could, but we don't like to because it looks ugly. All right. Moving right along. So tacos, we have 1, 3, 5. So y equals, our start was 1. We're adding 2 each time, so plus 2x. For our little flowers, we've got 4, 8, and 16. So we're times them by 2. Our start is 4, so it's y equals 4 times 2 to the x. Number 7, 1 on day 1, so we got to go back to day 0, don't we? 6, 11. So we're adding 5, so going backwards, 1 minus 5 would be negative 4, which doesn't make sense, but mathematically it works. So negative 4 plus 5x. Now, I suppose if you really were bothered by that, you could use your first term. Just like recursive, we could do a sub 1. I could go y equals 1 plus 5x. The problem is just having that x there throws off my numbers and it doesn't connect. So I have to recognize that I have to drop back 1, so I'd actually go x minus 1, and it would work that way as well. But I prefer doing it this way. Number 8, we've got to drop back to program 0, 5, 25. So we're either timesing by 5 or adding 20. Hard to tell in this case because we don't have any other numbers. For timesing by 5, we started with 1. For adding 20, we started with negative 15. So it's either y equals 1 times 5 to the x, or y equals negative 15 plus 20x. Okay, so sometimes that happens if you don't have enough information. Could be either one. Okay, number 9, start with 6. So we've got y equals 6. Goes down to 3, so maybe you're thinking, oh, I'm either dividing by 2 or subtracting 3. However, at hour 2 we have 0, so I can't divide by 2 and get 0, so I know I'm subtracting 3, so minus 3x. 10, we start with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Then we go down to 6, then 3. We're definitely dividing by 2 here, so I can go y equals 12 divided by 2x, or I could go y equals 12 over 2x. However, we generally don't like to leave it in division when we're dealing with geometric. They just don't like that, even though mathematically it's viable. So instead of dividing by 2, it's like we're cutting it in half. So we're timesing by a half. So we should go y equals 12 times 1/2 to the x. Okay. Alright, so we've got our pictures there. So let's take a look at some story problems, and basically we're doing the same thing, just finding out where it starts, how it grows. So 11, Grangelo is overcoming a bad injury that he recently had. His physical therapist had him do 3 push-ups today. There's our start. He has challenged Grangelo to now add 2 more push-ups to his amount each day. There's our growth. So it's arithmetic because we're adding 2 each day. So y equals, we started at 3, we're adding 2 every day for repeated days, okay? And there we go. So 12, there is a terrible problem at Tooele High School. Students are coming to school with dead fish in their pockets. The smell is horrible. Not true. Smakai, meaning the smell would be horrible, but it's really not happening. Smakai was the first one to do it. There's our start. And now every day it seems like the number of students doing it has doubled every day. Doubling meaning timesing by 2, so it's geometric. So y equals the first student, and they're doubling it every day. Mr. Vorwaller is recording the number of times he has to tell Olivia to do her work. So far he has told her 2,000 times. Start. Every day he has to tell her 15 more. Growth. Arithmetic. Y equals 2,000 plus 15 times x. 14, Grage is doing a science experiment. Yes, we will call it a science experiment, where he collects saliva from his classmates. He already had 5 ounces collected in a jar. Start. Gross start. Every day he works to triple meaning timesing by 3, the amount of saliva that he has. So y equals 5 times 3 to the x power. Okay, remember, if this one would have been plus 15 to the x power, it doesn't work. This one would have been plus 3, or no, sorry, mixing myself up. If it would have been times 3 to the x, that is also does not model the pattern that we're going after. Okay, so we got to make sure we keep those correct. 15. Joanna always asks Mr. Riddles if she can leave class to help a friend. So far this year, she has asked to leave 17 times. Whew, that's a lot of start. So y equals 17. Even if I don't know if it's arithmetic or geometric, I know to start with 17. Every class period, she asks at least 2 more times. So we're adding 2 to that and get 2x. There's a competition going on about who can delete the most friends from social media. Quaden currently has 34,280. He's eliminating half of his friends every week. So eliminating half, we call that dividing by 2, or timesing by a half. So we should really go with that route. We start with 34,280, and we times by 1/2 to the x power. 17, Mr. Vorwaller and Mr. Adults are being super strict about cell phone usage. So far this year, they have taken phones away 134 times. Every day, they take away 20 more phones. My growth, my start, y equals 134 plus 20x. 18. Vaden is looking to get into the cricket breeding scene for feeding to pet lizards and such. At least that is what he told me. He currently has 2 crickets. There's our start, y equals 2. And he figures that he can quadruple times by 4 their number every month, times 4 to the x power. Frack has to watch his sisters after school every day. His parents said that they would pay him depending on the hours watched. He makes $2 every hour that he watches his sisters. So we're adding 2 every hour, so I know it's plus 2x. But what's my start? Well, think about it this way. If you did it for 1 hour, you'd make $2. If he did it for 0 hours, he would make no money. So that's my start. So 0 plus 2x, or I could just leave it y equals 2x. That would work as well. And finally, Clayman decided to cut down on his sleeping in class. Currently, he sleeps about 40 minutes every period. So that's our start. He will cut the amount of sleep he gets in class by half. Again, timesing by a half for every period that he comes to class. So y equals 40 times 1/2 to the x.